Yeah, so me again, not supposed to be here, but talking about something. So this, I happened upon a patch set for TDX attestation reports, and the claim in one of the discussions was, I think I saw an email from Dave like, why do we need another character device in iOctl? And I think the justification coming back was like, well, AMD got away with it. Can't we get away with it too? And the claim was like, oh, like there's no kind of framework for this. And I was like, hold my beer. Let me put this together. The assertion is that if everybody is doing the same thing, they should probably be doing it the same way. And this is a hard concept to get across to the kind of the back end of that, the saying, oh no, but the TDX is different than SMP. Like the adaptation reports are different. But like a funny thing happened, even posing this question, is that like this started off as a keys subsystem thing, and James like this doesn't belong in keys, but James was able to had an opinion like about like this should be unified but not here. But then the keys people got involved and they started talking about like the community started to grapple with something. Like once you say, hey community, this is going to be the common thing, people come out of the woodworks to start to define it. Like, and once you kind of try to put it into vendor corners, like nobody reviews it, and like I think it shouldn't be the case that you're trying to get away without people not reviewing your stuff. Like and the goal of bringing these together is that people have a common language to negotiate things. So it's just better all for the community if we're all behind the same ABI. The other thing is that also I learned a lot about attestation reports I knew nothing about before I started this. Was that there's some nascent efforts to try to do an industry standard on this, but things haven't come together yet. But this kind of points to an operating system's role. Linux's role is kind of the consortium of last resort. It's especially like we're the last link in the chain that has to deal with the differentiation. And our first inclination, our instinct is always say no, like don't differentiate, like if you don't have to. So kernel has a role here to try to get the standardization that didn't happen beforehand. The other role of the kernel here is the keeper of the ABI. So if somebody rolls their attestation report format in a binary incompatible way, the bug report is going to go to the kernel, like because the person the ABI contract that the kernel exported to them was violated. So that's a kernel bug report. So the kernel has a role to play in trying to enforce that those things don't happen. One of the ways that the kernel, this combined interface does that is by putting people's attestation report formats in the kernel's ABI documentation. So if you've read the documentation and you've written your thing to that format and that format changes, that's a kernel bug. Well, that's you've broken ABI, and kernel has we have ways of dealing with people that break ABI, and one of those ways is like, hey, it seems like you're not ready to stabilize your format. Maybe we shouldn't be exporting them at all. And they go, wait, no, we won't break it. So like, there's those kind of those are kind of the only things that the kernel community has to get kind of ABI compliance is code acceptance, like and the threaded rebirths. We don't really have other mechanisms. Except I wanted to highlight this as an opportunity. Like I know Dan posted this proposal about having people come together. So in terms of trying to get to the point where we have a forum to do these things, I just wanted to highlight, I don't know if you know about this process called Code First. It works amazingly well in the ACPI working group. The ACPI specification moves kind of slowly for publication, but an open source moves fast. There's several cases where the Linux community or the Tiano core community, they identify a need for a change well before that consortium does. And the way that process works is you develop the idea in the open, and then you ask the consortium to ratify it, and they say yes, this will appear in the next spec. But it bypasses this whole kind of confidentiality, can't talk about it for a year kind of problem. And the idea here is maybe this is a forum where we could have a code first process for confidential computing, where we say, hey, it'd be really nice if all the vendors agreed about this and ratified that in somebody. And I realized I didn't actually introduce what we're talking about here. Trying too well. Let me. The right arrow key's not working, guys. What? At the graph presenter? Oh, okay. Okay. So what this was is that SEV and TDX have a way to ask basically the TSM, the same thing we were talking about before in the last presentation, the TSM, give me an attestation report of the state of my VM. AMD has a format, TDX has a format. The going in position of this solution was that we're going to accept that those things are different and say, okay, here's what you have today. These are the formats, but we're going to transport them over a common transport. Actually, let me show you this data structure. I love this data structure because you could basically implement pretty much any ABI on the planet with outblob len, oxblob len, oxblobs, like blob blob blob. But I mean, but at least it gets us to the point where we can talk about the transport and people can have discussions about, hey, what do you guys put in oxblob? Oh, we put a certificate store in a specific AMD format. Oh yeah, oxblob over on Intel is the same thing, but in the Intel format. At least it's like put the same things in the same places. We do so, but back to how people actually use this thing. So there's a TDX guest driver. There's a SEV guest driver. They both call TSM register. They export this TSM interface in configfs, so you can make as many of these configfs instances as you need. It is configfs, so you do need some user space brokering if you think people might collide on that. And then you just say, hey, here's 64 bytes, because both Intel and AMD both need 64 bytes. They get the report out, and it comes back out in the format. And it's pretty dead simple. So it's upstream. So like there's not much to talk about this, but this was more about having opportunity to talk about the concept of getting in the same boat and aligning on things. So I wanted to open it up to discussion if people have questions about what this thing was and how it came to be.
I have questions.
Hey, surprise!
Always. So just coincidentally, I finally, hopefully, unless after this conversation, Greg is going to pull it up again,
Yeah.
we'll have yet another driver upstream that is going to do the same thing, gets another character device that is
like this. So
another attestation report format in CBOR, amazingly, called NSM, the Nitro Secure module for Nitro Enclaves. And one of the things that, like, I was as part of the upstreaming process, where we were pondering about the nice user space interface to access that device, because it actually is a multi-function device that gives you an RNG, a hardware RNG, as well as random other metadata things, as well as an attestation document, right? I was pondering on how to do the attestation thing well, and I couldn't. Like, originally my reaction was, hey, sure, this could just be a sysfs file, right? Easy. Until I realized, no, you actually have a nonce that you can provide. You have a public key that gets embedded into the attestation report that you can fill in of like up to 3 kilobytes. You have another piece of random user data that can provide anything it wants in binary format that gets embedded afterwards. And so you just don't have like a simple file system like Semantic you can use for this. And then you're basically back to, oh, we should do ioctl or socket-like things, and then you're back to everything is specific anyways.
Yeah. So what I don't know is because I know there's also TPM can do attestation reports, and it has its own format.
It's much more complicated than any of the same things.
Yeah. I mean, I don't know the details of your thing. This one wasn't a good fit for TPM because it's kind of like a fundamental asserting the state of the VM to start to do other things. But I saw one discussion in I think Tom Landacki and as well, we're talking about VTPM and this idea of in the attestation reports we have 64 bytes, but what the proposal was the 64 bytes you put in there is a byte that describes kind of the record, a hash of however much data you want to put in, and then like the nonce as well. And so that so with 64 bytes you can do a lot. And can we use this? I like the cleverness of just putting in it, putting the hash as and mixing with the nonce and get a report on that. Well, yeah, so they can use this.
Okay, maybe.
I mean, but this basically is.
Did you merge it yet? Like, is the TSM stuff?
Yeah, it's merged. Yeah, I mean, but to your point about this is a multifunction device that can do other things. This is kind of also inspired by the way David Howells did the keys interface, where like you have the TPM driver. The TPM driver has its own ioctls, but it also registers a keys interface, so you can do the key, like the Linux keys can do TPM things through that ABI, but you don't. But you still end up having two ABIs. But like, so this is the attestation report ABI, but like the sev guest ioctl is still there. We did intercept the Intel TDX ioctls. So there's no Intel TDX ioctls for this, but you can still have your other ioctls and have this cake as well.
Yep. Okay, cool.
Just getting away from the attestation stuff, I feel like with
Oh,
the attestation things, it's like the tip of the iceberg. Like we're solving the stuff that doesn't actually cause the kernel that much pain when we talk about how different TDX and SMP and all the other flavors are.
Yes.
Do you see this actually? Do you see us moving the needle on the giant iceberg that's sitting below the surface?
So one of the things, yeah. So basically, this is kind of like my entry into this. Like if we can't simplify this, then like like this is like the starter. But yeah, so then level 2 is like, I'll show a picture in the BOF about how we had a discussion with TDX Connect is the same, is the Intel version of AMD TIO. And I had a very productive discussion about, like, you know what, yeah, AMD drew this line in a different place. And I'm like, yes, I agree that, from my perspective, yeah, that makes it easier on the kernel. And they said, yeah, let's try to move our interface to that. So that gives me hope that we can have these discussions about, like, if not like getting people to standardize, but at least saying, like, if somebody's going off the complexity relative, we can bring them back to baseline. So we still have the mountain of complexity beneath here, but at least like we don't let the stray bullets fly. Oh, I thought you were trying to tackle me. Yeah, okay, good. Okay, thank you.